Um, and in the process of setting that up, I did an experiment yesterday with monitoring. And anyway, it was a setting in OBS. Thank you guys for pointing out there's no audio because um, that's kind of a bummer. So um, without the face cam, I think it might have been not obvious that I was actually talking the whole time. With the face cam, it is obvious. So, thanks. So, what we're about to do is test this transmit function on USART. And I think what do I want to do here? Yeah, that's what I want to do. So let's just assert equals. And wow. We expect to see the test byte on the USART. So in this case, we need to go through this whole dance. Can't type. Okay. All right, let me tweak another thing here. All right, it's a little better. All right, so Circom 1 in USART mode, and in here there should be like a data register, whole bloody thing. All right, and because we're using a new thing, because we're banging sticks together here, we need to do that. Okay. So we'll do typing. So let's do this and run the tests. Let's put this guy more over here. Yeah. Undefined reference to USART. So we get the linking issue. So this goes over here. So let's just take the signature, and for now we're just going to stick it in here, like that. And so now the test should fail. Good. Test 75 is failing, and as always, we're going to do the cheaty thing because we've actually already said what we're going to do, and this is the value. All right, so now we should have a passing test. So, however, this is not everything we need to do here. Should have. Let me open the data sheet to the controller. It's here. And we can't just, or we shouldn't, just write to the data register willy-nilly like that. We should probably interrogate the status register. Frame error, buffer overflow, sync, or maybe it's in a control register. Where? Or it's in here. Yeah, it's in here. So the data register empty. So it is set when data is empty and ready to be written. So we have a precondition of this line of code that is that that this bit be set. That's a precondition. If it's not set, we're just going to wait for it to be set. This is where interrupts come in handy in doing interrupt-driven I/O. I'm going to do the simplest thing it could possibly work, but it's still correct. And we're just going to busy wait on this loop. And this is going to point out an interesting thing about TDD. So what I'm going to do is I'm not going to do TDD, and I'm just going to go ahead and write the code first, right? And what we're going to do is we're just going to say, wow, usart stuff dot, and it was in this flag register bit. I think it was the DRE bit. And when the DRB bit is, we want it to be set. So as long as the DRB bit is cleared, we're going to busy wait, right? So this is your typical kind of busy wait thing. Maybe they put the exclamation point instead of the explicit conditional, whatever. It compiles to the same code. I think this is easier to read, but whatever. And in fact, we're going to do it the other way around and do that. I discussed why we want to do that in the other stream. Didn't catch that, ask me and I'll explain it again. That's what we would do for a busy wait loop. Now to run my tests, we're going to go in here and we're going to make that a 1. Like that. And now the tests, I think the tests will run and pass. Okay, so here's the thing. What if we wanted to unit test this? What if we wanted to test that this waits until this bit is set and then writes the value? At least with this test framework, we have no way to do that. And that's bad. And that's telling me that this whole busy wait thing, at least my conclusion after thinking about this for a while, is that busy waiting in general is kind of a bad idea. I mean, this isn't what I would call a best practice, but it is a good enough to make it work practice. So, it's Twitch is an interesting beast, you know. So when I started the stream, I had more information on my screen. When I restarted the stream, certain pieces of information just kind of disappeared. So interesting. So, there's what I was getting at is there's no way, at least with this test framework, to test this while loop. And to me, that means we probably shouldn't do it this way. I'm going to go ahead and do it this way for now. And maybe we'll come up with a alternative later. So what I am going to do is a to-do remove busy wait loop. And we'll go from there. So we at least have a way to TX data, because we're also going at 9600 baud. The probability that we'll hit this loop and be waiting for a long time, at least on processor time scale, is pretty good. So this is probably not a good way to go. Go with the interrupt driven thing, or maybe something else. So yeah. All right. But we have our basic transmit thing. So now I think we want to get to main. And in addition, I'm also going to say you sort tx a plus key. So if we remember right, key is one of these enumerated values. And so by doing this usart thing, we'll also output in this little test program a key. The other thing we can do in this little test program is, because we also have our LED. So let's set the color of the LED based on the key, and we'll just do a mod LED number of colors, and that way we'll be constantly updating the keys or the LEDs, and when we press the key we should get some color. Don't know how long this delay is. Oh, we're not scanning, so we're just going to cycle through. I'm sorry, I was thinking about this wrong. This presses a key on the chem pad side. We're not doing anything on the keypad side. What I wanted to do is oh, we haven't written that code yet. That's why. Yeah, we just have a low level row and column code. So we haven't actually done like the scan thing in the keypad. So maybe we should do the scan thing in the keypad. Now, do I want this to be public function or private function? All right. Again, checking things. So I wonder, thinking back to our issue earlier, so I have like audio meters in OBS, but those are audio meters on the input to OBS. I wonder if there's a feature in OBS to meter the audio output. If that would have told me straight away that there was an issue, because I'm not listening to the stream. That would have been another thing to do, is listen to the stream, which I could do in my headphones without feedbacking to the stream itself. Anyway, it's fixed now. Let's think about what we're doing. So I wanted to go to the keypad. And in the keypad, we have this column select row read business. And so in here, oh yeah, this is gonna be good. Okay, so let's do that. So we need a test in the keypad, and we're gonna take this, copy, paste, and we're gonna call this test test scan. I remember why I didn't write this good before. I remember now. Okay. I didn't write it before, and there's a reason. So, this has mocks for the init things, but I think we're gonna want to mock this and this. So this is a mock void 1, and it takes one parameter. And this is a mock value, and it returns that. And we need to reset them. And the other thing I'm going to do is I'm going to declare them in opposite order, because I always do this stuff in, I'm sorry, the order was correct. I always do this in alphabetical order. Not a big deal when there's 2 of them. When there's 10 of them, it's a readability thing, and alphabetical order is as good as any other order. All right, so this test goes away. This is the test for the scan. And now we need to, this goes away. And now we actually need to come up with a test. So what is our first test? First test should be, I think the test is no keys pressed. That sounds a great first test. Static void thing. void thing. We always call setup. And then we're going to call keypad scan. And it's going to use a keypad e.t result. So at this point, we're just making stuff up. And no keys pressed, no keys pressed. Test scan. So let's create a scan.c. Oh, sea lion is helping again. Go there. And we know we need to include our keypad P private header. And let's make sea lion happy. And maybe at some point we'll fix that more permanently. All right, so now we have red, which is kind of what I was going for. We have red here too. Closing quote. Okay, so now it says, never heard of the scan thing. I never heard of this keypad type thing. But I know that I have a keypad scan void. So that helps part of it. But what is this keypad thing? And here we're going to say type def enum thing. It's one of those. We'll figure out what goes in the enum in a second. Keypad P calls imports keypad. Keypad has the keypad thing. And we'll say keypad number of keys. So that this has one thing. Now there's probably some other stupid syntax. Unused variable result. Okay, so assert equals key add no key. And result. Come on. Result. Never heard of keypad no key. We'll just stick it in there for now. And now it should not link. Yes, undefined reference to keypad scan. So now we can take this guy, copy, come over here, and declare. Let's declare one of these and return keypad no key. We have to return something that should pass. Okay. Ta-da. Stupid easy. But let's, what's another thing we need to do I mean, the other thing would be a key pressed, and we could test for all the keys. Maybe we'll do that. Um, yeah, so the test will become more sophisticated here as we go along. So let's test for key 0 being pressed. Static void, name of the thing, void thing, setup, and then I'm gonna call scan, and should have just copied the whole thing. And we're going to assert keypad 0 key. All right. There's probably more we need to do here. Let me open the schematic for this guy. There it is. Here it is. Let's do that. All right, so here's the schematic. So we're testing that this key is being pressed. And so that is row 5, column 0. Row 5, column 0. So in our test here, we need to select column, so we're going to assert that the column select is called with keypad column 0. Okay, so we're going to assert called 1. So we're going to assert that that this was called with column 0, and then we need to do a mock returns on keypad row read, and we want it to return a keypad row, what did I say? Row 5. Okay, so with row 5, column 0, we should get the 0 key. And I'm going to put the 0 key in the enum. That. Okay. And if we call this now, this of course is going to fail. Assertions. Okay, so line 31. So I'm also going to reorder. I'm also going to reorder these assertions. Like so. And it's just a form thing. So usually the result is the first assertion, and there's other things that are called. So now in one case, we need to do the one thing in the other. So I'm going to say oh, chat, I just got a notification in email saying that the circuit boards for this keypad project are expected to arrive on the 28th. So, sounds like we have like, that's in like 5, 6, 7, 8, 5 days. So, hoorah for that. So we'll probably have yet another software stream, or maybe I'll stream something else. But just got the notification that the expected delivery date is the 28th. So, yay. It's the slowest slow boat from China. So, I now know not to have things shipped in this way. So we won't do that again, because this is I ordered these boards on the 4th of July, and it says they're going to be arriving the 28th, so that's 24 days. It took the board house about 4 days to manufacture the boards. I'd have to go look. And the rest of this time has been shipping. So, shipping that takes, just a few days is not that much more expensive than the lowball shipping that I did. So, at this point, I wish I had paid a little bit more to get the boards, because, to be honest, I want to get on to the actually working on the Kim and stuff. So, anywho, we were going to stick in a thing here. What was I doing? I was going to call Reed. And Reed returns a row thing. And so we get row none or stuff. So, but we know that if it's row 5, okay. So now we have to figure out how we're going to factor this code. So for now, let's just do the stupid thing. So if it's row 5, then return key 0. It's not quite right, because now we're going to fail this other assertion, but let's see that other assertion fail. Line 7. Right, so this is happening because row read needs a return, and we're going to say row none. All right, so now if we run this, 35. Okay, so if it's this, So I'm going to start thinking more about what the actual algorithm is here. But we're just kind of doing the TDD thing of, so what I really want to do is set the column and then read the row. And all of the tests passed. So obviously this is crap code, but we will get there. So let's add another key. Like key 1. Which looks a lot like key 0. Okay, except key 1 is row 5, column 1. So row 5, column 1. And that fails. And we need key 1, which we'll do like that. And so now 45. Yeah. So this is row 5, column 1. So I'm going to write the crap code version first, and then we'll refactor it. And the crappy version looks like that. So, this should make our tests pass. Nope. 33. Huh? Oh, interesting. Interesting. So interesting. So what I need is I need what? So this is failing because we're calling column select, and we're calling row, and the row is 5, so it's saying it's key 1. So what I really need to do is I need to change what row returns based on what column is actually selected. All right, this is interesting because this is a use case I don't think well, this might have come up before. This is a super advanced use case though. So what I think I need to do, because I need to change so in this case, when we read row 5 and call scan, I need column I just had it. All right. Keypad scan, the third equals keypad 0. Let's that. Keypad 0, column 0, column 1. So, oh yeah, so this is going to cover a lot of logic. So, would it be easier to do if we were to go the other way? So instead of keypad 0, we want to keypad to key 4, because that would be the same column. Either way, we're going to have to do the fancy refactoring of everything. So, but that would put us, that would demand the row thing be different. Now let's just go down this path. So we're going to have to address several things at once here, which in a way is kind of stupid interesting, and in other ways is kind of hard. But I think we'll get there. With like tests and everything. So what we need to have happen is we need to call scan. And in this case, it does this. And it does this because when we call with column 0, read returns 5. And in this case, when we call with column 1, it returns the 5, and any other column, it would return no key. So we need to add that logic to our mocks. Which is super interesting. So what mock do we need to add it to? I mean, I think this crappy code is okay. We need to fix the tests to emulate the hardware better. So what did I just say? I said that when we call with column select 1 and we call read, in one case we need to return no key, keypad row none, which I think is a thing. Yeah, keypad row none. And in the other case, we need to return row 5 based on the column, currently selected column. So the behavior of one thing depends on other. And we need to set this up in our tests. Okay. Okay. So what I think I want to do is I think I want to add a parameter or two to setup, because we want to change what this returns based on based on the column. Okay, so we need to do a couple of things here. So first thing I'm going to do is I'm going to say that setup takes parameters, and this parameter is the keypad row and a keypad column. And this is going to be the row. The row column for the when we call so we want to change the mock for read. All right, so I'm going to say static void test row read, and this has to match the signature, and or mock custom. All right, so this is a, and then here, the value returned for the row depends on the column. So what I'm going to do, say test column, and if the test column equals the test selected column. Like that. Then return test row. Else, otherwise, return keypad row none. This is a row. Row. And the test row. I'm not gonna do this way. We're gonna leave setup alone. Oh, down here. We're going to say the test row is 5, right? And the test column is 0. In a way, we don't need to do that anymore. What we do all right, so now I have a decision to make. one of the things I could do, yeah, let's just do it this way. Um, this guy. This guy. All right. When you complete with tab, then everything of the old variable that's right of your cursor is deleted. Very helpful. Yes. Sometimes it does helpful things, sometimes less so. And hello. I'm not even gonna. My eyes are not great. I'm not even gonna. Reading is not my thing. I have dyslexia, so here. Hello, Rutin. Hello. All right. So, what are we doing here? So we set up the custom things, and then in this custom thing, we retain the state of a column. And this is kind of like mocking the hardware and outputting the column here on these guys. Here on this port. And then when we call the row, we see if the test column is the selected one. So this test column thing is here. All right, so I think that's what we want to do. So if we copy this, replace this with this, and we said the one key is on column 1. So now, if we run the test, what happens? Wow, test path. So I think we address the complexity in the test configuration for all the keys. Now we have crappy code to address. So, but before we do that, let's do another key, but let's do a key in a different row. So let's do doesn't matter. Let's do the 4 key next. So we'll probably do all the keys at some point, but testing the 4 key next is going to drive the design and architecture further. 2 and 3 keys are kind of redundant to what we've already done. But the 4 key is in row 4, column 0, I believe. And we want this to be the 4 key. Now I'm going to delete these assertions. And do more of a functional test for this guy. So we don't know what a 4 key is. So let's do that. So now we know what that is. So if we run this should fail. Okay, fix the typo. And line 72 says never heard of it. Expected to actual 3. Interesting. All right, so 3 being no key. Yeah, no key. So that means it fell through everything, which is kind of good. So in this case, we're in column 0, 4. So to make this work, we would do that. And that, of course, is horrible code. And it didn't fix it because this is the 4 key. And now let's see if everything's happy. Okay, so we're probably prepared to address the crappiness of this code in a reasonable way, because we have enough test coverage to address enough of the use cases that we could probably do that. I'm tempted, though, if we want to do the 5 key as well and cover 2 rows and, all 4 permutations of 2 rows and 2 columns. Nah, let's just go with what we have. So my first observation is we could take this whole mess here and put it up there and fix the silly C thing, and this should be the same. All right, so it looks like we're iterating columns here. So let's do that. So let's write a for loop. Keypad column T equals column 0. We need a name. Column is less than keypad the number of columns, column plus plus, and I commented earlier in another stream about changing column to call because it makes the names big, and I don't know that spelling out column is all that necessary. So now, if we get rid of this guy, now if we just take this and stick it in there, and we take, what did we do? Took this, stuck it in there, and we take this and stick it in there. So that's not quite right. So depending on the column, we want to change our things. So more. So this should fail, I guess is what I'm saying. Let's see it fail. It should fail. I'm expecting it to fail. Depth 5. So it failed. So let's change this to 10. And all right. Line 50. This is what I expected. Keypad 0 key fail. Obviously, this is funky because we have read a row 5 twice with different keys. And as that's what's happening, expected 0, actual 3. 0, 1, 2, 3. So is that failing? Oh, we need to call column select. So again, we're expecting this to fail, but in a 61. Yeah, so we're expecting this case to fail. Because it should be reporting key 0, and it should be 1. Right, so that is now failing. So I think I see this. I can see ahead to what we need to do, or where I want to go, and I just need to decide how to get there from here with refactoring. So, but I think we're just going to go for it. So what I'm going to say is this is a const key keypad key thing, and it's the keypad key map, and this is going to be columns, and this is going to be number of rows. And we're going to initialize it so that keypad column 0 I believe we can do this. Keypad okay, column 0 row 1, column 0 row. Interesting. 0. Yeah, so row 0 is 0. So 048C. So this is going to be, and we'll just do the ones that we have. 0. And 4. And then column 1. Is 1. Like so. Now, with that mess in place, and then we need, we need more. Return key map with column and the row. But if the row is keypad row none, then continue. Otherwise, return. So I think that's actually the whole function. Let's see if this passes the tests. '61 fails. Keypad 1. Right, because we have other rows. Keypad 1 is row 5. And so we need to populate the other rows in the array, which means we need to define all the other keys. So I think it would make sense from a logic point of view to change our tests and test for 0, SST, RS, and 3. And I would kind of test and then no key, of course. And that would kind of test the boundaries, although really what we need is one test at some row and column, and then maybe another test that tests the data structure, which is kind of what I've done in other parts of this code base. So key, I like testing for key 5. So let's row 0, row 5. Yeah. So let's keep the tests that we have. Let's populate the table, but we're going to populate the table with a test, of course. Test key map. Static void. Test the key map. Void. We the always call set up. Always. And now we have a bunch of assertions. And this is going to drive us crazy to type it all in, but it will be good. So row 0, column 0 is SST. So we're going to have keypad key SST, and that's going to be at what did I call this? Keypad key map. And this is going to be column 0 and row 0. And this guy becomes a extern, like that. And now it never heard of SST, so we'll stick it in here, and then we'll think about the order and stuff later. All right, so this should fail because, yeah, never heard of it. So now 0, 0. So now we can come over here and pick up our SST and paste that in. And one of the things I want to point out is, like, this testing and stuff, it's really boring, right? This is not like exciting. When we get to the hardware stuff, that'll be exciting. When we power on the board, that will be more exciting. This is like boring software stuff. And I would argue that that's part of the point. Still failing. Why? We're in column 0. This is row 0. Ah, this is row none. This is row none. So we can either put a sentinel value in here like that. I think that will make that pass. Or, and then the other things fail because our table isn't right. Or, I don't like that. What if we move none to there? And I'm going to do the same thing. I'm gonna all right, I'm gonna say okay, so first thing, keypad. That's not what this is. This is keypad, all one word. Keypad key SST, or just keypad SST. This is the public header, so I like, so we're like 3 or 4 changes deep here, but I like that. And so we'll shift F6. Okay. I kind of like that. All right, so if I do, did not work. Shift F6. Shift F6. Yay. All right. Keypad 1. And shift F6. Keypad 4. Shift F6. Keypad, no key. Good enough. And I know the 4 is goofed, but it's gonna get deleted anyway. So, Nookie. So now, how are we doing? 68. Yep. We'll get there. So, 0, 1, 2, 0, 1, 2, 3, 4. SST. So it's SST 80 C8. All right. C8 4 0. Right? So we need 80 C and 8. Eight and C. So now test should fail. 80 is not in the table. So it goes ST 80 C 8 4 0. Right? 048C. 048C. So now one is failing. That's the next column. So let's put in, copy this, and put in the next column. And that is go DA. So this is go DA D951. So should be one more. D9, 5, and 1. Never heard of most of those. So so we have go, and we have DA, and we have D, and we have a 9, and we have a 5. And the assertion fails because we didn't populate the array. But that's okay because this gets go and a DA, D, and a 9, and a 5, and a 1. Three. Column 1. Oh, no key. And now all the tests passed because we covered these 3 buttons. So let's do the rest of the key map. So we have all the keys. So column, this is rinse and repeat. 2, I'm going to copy, paste, 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 paste. And the keys are STPC. So this is STPC EA 6 and 2 and EA 6 and 2 and okay. So have an ST. Like I say, I will likely reorder this enumeration once we're as a step later. We need an A. We need a 6. And, you know, we don't need TDD to figure out what our enumeration needs to be, but right. But this is helpful for making sure all our Cody bits are correct. So no key, ST, PC, E, A, 6, and 2. The other thing I wanted to mention briefly is if all I wanted to do is create a debounce keypad for the Kim, I certainly could have done it with less stuff. But part of what I'm trying or attempting to do is actually demonstrate, is not just build the keypad, but to demonstrate like test, oops, off screen, test-driven development and how you would do like professional level embedded development stuff. So it isn't just building the keypad for the Kim. That's just the context for what we're doing. All right, so that's good. So I think we have one more column. Yeah, one more column. So this would be column 3. And column 3 is RS plus. All right, so this is RS plus C, D, E, F, B, 7, 3. RS F, there's a plus in here, B, 7, and 3. Okay. So this should fail. Insertion, so it compiles but fails. And it fails, of course, because we didn't populate table. And this is RS plus F, B, 7, oops, 7, and 3. Isn't it nice that it told me what was wrong? Okay. So the issue was the comma. I changed this 3. If I put it back the way it was, because I forgot to change that to a 3, if we run our tests, the tests fail. That's why we're doing this. That's why I created these boring assert equals with all these constants, is because I forgot to do something and the test is telling me you done screwed up. And I can stare at a while and say, oh, I need to make the 2 a 3, and then life is good. Okay. Now, these are kind of redundant, but I kind of like them. Because it does test the row and column logic. Should we add one? I mean, we could add one for the RS, but it doesn't just because it's the opposite bound of the 0. Let's do RS. So let's do key. Just to cover the boundaries, RS. So this is just a test to kind of harden the whole thing. So RS is column 3, row 5. And this is key RS. So that should pass. Perhaps we should move 4 up to SST and 1 to, yeah, let's do that. So let's refactor the test and change 4 to SST. We have key 0. And then let's test key 3. And then SST. And then RS. So this is 3. Which is column 3, row 5. So I'm column 3. There it is. Column 3, row 5, keypad 3. This one is SST, and it should be column 0, row 0. Oh, I have ST in here twice because there's the ST key and the SST. So it's SST. This needs to be SST. There's a gotcha. Key add SST, which is a special key anyway. Talk about, there's more to the SST story. And then in here, which is what I should have done in the first place, this one is SST. And then 116. So yes, RS is column 3, row 0. All right, there we go. So is there anything more in this? Oh, that we want to change. Honestly, I think it looks pretty good. All right, so let's order this enumeration correctly. So it needs to go 0 through F, and then ADDA. 0 through F, AD, DA, PC plus, SST, although SST, yeah, SST. SST is a special key, go STRS, go STRS, no key. Okay, so it's kind of in keypad order. SST is going to require other handling, but we'll get there in a minute. That's not this code's concerned. So, all right, so everything's still working. Still don't have hardware, but we managed to write code anyway. And I'm pretty sure this is correct code, and I'm pretty sure we'd have to write this code even after we got the hardware, and I'm pretty sure we would have written exactly the same code. So, because we're depending on abstractions, not hardware. So, that's why. Is there anything else here I want to do? This should be pretty efficient. This doesn't do debounce yet, but maybe it will in a bit. And I'm gonna do a streamy thing here. All right. All right. So, what more to, what to do? What are we on time? All right. I streamed, I think, roughly an hour and a half. So 3 hours. 3 hours today. What else do we need to do? So what I wanted to do, so let's close this stuff down, and let's go back to our main. And what I wanted to do was I wanted to say keypad key scan, and we'll rename this in a sec. And how I want the keypad to be the color, and actually I want the keypad to be the one we send out the UART. So no key is going to be some lowercase letter. All right, and then this we will refactor, and that's not the keypad. I'm just going to call this the KimPad. There. So now we're going to press all the Kim keys, and then we're going to scan and do that. And then we're going to have this big old delay in here for everything. So this is going to exercise the LEDs. It's going to exercise the UART. It's going to exercise most of the KimPad stuff. So over here, let me click that guy and that guy. So we're going to exercise all the circuitry over here. We're going to exercise scanning this. We're going to exercise the LEDs, and we're going to exercise at least the transmit side of the UART. And if the transmits, and then we'll maybe test the receive side later. I do want to use the receive side, but if the transmit's working, then the receive should be pretty close. And then the only other circuitry here is the voltage regulator stuff, which we're going to test manually. And then the only other thing is this stuff here, which is the connection to the debugger and whatnot. So when we get the board, the first thing we'll populate is this voltage regulation circuit, and maybe these chips and all of these pull up, pull down resistors. But we'll do this first, verify that we have 3 volts. So that'd be this regulator and these caps. And then we'll do all of these chips and resistors. And then we might as well do the we might as well do the rest of it except for these keys and the actual header. We'll go ahead and do this header. We'll go ahead and do this header. And we'll go ahead and do the LEDs. So, I think that's everything. That I want to do in the code at the moment. So let's commit. And what we did is we added a keypad scan function. That's what we did. And this should be committing all the stuff. And we tweak the art and stuff. Okay, so commit. Now it's in version control. So I think that's all I wanted to do on this project. Why is this green?